Recording has started.
So for number one, we have to identify the relationship between the angle we're given, in this case the 58 degrees, and the one we're looking for, the x, so to then find that missing angle. These two angles form a straight line. They're a linear pair. So they have to be supplementary. They have to add to 180. So 180 minus 58 is 122. So x is 122 degrees there. In number two, we have the 81 degree angle, and we're looking for angle y. Those are vertical angles. They are across from each other on intersecting lines, which means they are the same angle, same measurement. For number three, these two angles, z and 63, add up to a right angle, which means to find z, I subtract 90 minus 63 to get 27 degrees. So z is 27 degrees there. And finally, number four, these three angles make a triangle, and the angle sum of a triangle has to be 180 degrees. So I can do 180 minus 92 and then minus another 39. Gives me 49 degrees for angle W. Problem number 5 is a different type of problem. It's talking about variation. We have our first piece of information. P varies inversely with M. So that means P equals a constant divided by M. That's what the inversely means. Is this going to be that form of an equation? Next, we are given a known set of values. M is 4 when P is 12. So put in 12 for P and 4 in for M. And now we can actually calculate K. We multiply by 4. 12 times 4 is 48. On the other side, the 4 cancels out. We have K equals 48. So we can combine that with our original form of the equation. Instead of just P equals K over M, P equals 48 over M. And then we're asked find P when M is 6. So we put 6 back in there for M. P is 48 divided by 6. Or P is 8 when M is 6. I wanted to go through those problems here because those problems are very, very similar to the ones on a quiz that is due today. Technically a quiz for today that's due tomorrow. It'll be due at noon tomorrow, December 16th. Also, make sure you look back. There are several of you that are missing quizzes and tests over the last few weeks. So make sure you go back and look, and if you're missing anything, get those turned in. Right now, if the semester ended, there would be a couple of people that would need to retake math, and we don't want that to happen. So make sure you're going back and looking and seeing if you're missing anything. So turn in, if you can, any missing quizzes or tests. And then if you have any low scores, you can redo those and turn them in and get back up to half your points, especially tests. The reason I say especially tests is just because there's more points there to get back. If you have an 8 out of 10 on a quiz, that's 80%, but you only get back 1 point if you redo it. If you have an 80 out of 100 on a test, that's still 80%, but you can get back up to 10 points for redoing that. And you're working on total points at this point. If you have any questions on that, get in touch with me and I can help you look through and see if there's anything you still need to do. Okay, so today we're continuing on this geometry theme. We did the angles over the last class. We've talked a little bit about area before in Unit 2 as far as following formulas. And if you remember, we said it comes from, again, just like our angles derive from that single point, we take that point and we move it in a single direction to get a segment. But the length of that segment is equal to the distance moved. Next, we take that segment and we move it in a second direction perpendicular to the first. So if we take it and we pull it this way, if you think of it as like dragging a stick across the sand or whatever, it's going to leave the impression of a rectangle. That rectangle is now two-dimensional and can cover an area. The amount of area that it covers depends on the length of that original line segment. And once again, the distance moved. That distance is typically referred to as a width. So the area of a rectangle make this legible. Is equal to length times width. If I have a rectangle that is 8 inches by 13 inches, so 13 inches here would be our length. The area would be 13 inches times 8 inches. So remember, when we multiply, we combine counts. 8 times 13 is 104. But we also combine the names. Inches times inches is inches squared, or square inches. Well, we did all that with rectangles back in Unit 2, as we said. But there are other shapes that we can run into. This is a parallelogram. If I give you that this is 15 inches here, and this is 10 inches, I cannot use those dimensions to find an area. Find area, we need two perpendicular dimensions. Remember, perpendicular means they have to form a right angle. These two dimensions do not form a right angle. So the dimension we need would look something like this, forming a right angle to the 15. And at this point, all we know about that dimension is it has to be smaller than the 10 inches, because the 10 inches goes at an angle. The perpendicular is always going to be shorter than any slanted line. I'm just going to fill in a number, and let's say that we are told that that is 8 inches. So now the area of a parallelogram is going to be a base, which is basically a length, that's the 15 is the base, times a height. And a height is always perpendicular to the base. And it reaches to the furthest point of the figure. So in this parallelogram, the furthest point of the figure is just this opposite side. The furthest point away from the base is just that opposite side, and it's parallel. So that height could be anywhere along here, actually. That would all be 8 inches. So for this parallelogram, our area is 15 inches times 8 inches. 15 times 8 is 120. And again, we multiply the names. Inches times inches is inches squared. We looked at triangles briefly. A triangle, let's say I know that the bottom here is 20 feet, and the side over here is 7 feet. The triangle can be thought of as part of a related rectangle. A related rectangle is the rectangle that is the basis of a triangle's area. Well, what do I mean by that? Well, here, this related rectangle has an area, put it this way, area for the rectangle is 20 feet times 7 feet, or 7 times 20 is 140, feet times feet is feet squared, or square feet. That triangle is exactly half of that related rectangle. So to find the area of the triangle, it's just the area of the rectangle, 20 feet times 7 feet, divided by 2. So it's going to be 70 square feet, or feet squared. Well, this is a right triangle, meaning it has a right angle in it here. Because it's a right triangle, that length and width of that related rectangle are just going to be those two sides that make the right angle. They are referred to, just like in the parallelogram, as a base and a height. The reason we do that is because they're not always, not all of our triangles are going to be right triangles. We could have a triangle looks something like this. If I am told that this down here is 25 inches, my related rectangle, if that's my base, my related rectangle looks something like that. Well, what I would need to know in order to find that area is this width. The 25-inch base of the triangle is the length of the rectangle, but I would need to know that width. And where that's found on the triangle is right here. That is a height because it's perpendicular to the base, and it goes to the furthest point in the figure. The furthest point in a triangle will be that opposite vertex or opposite corner. So if I tell you that that is 7 inches, let's go 6 inches. So, oh, what the heck? The area of that triangle is going to be the area of the rectangle, which would be 25 inches times 7 inches divided by 2, because the triangle is half of the rectangle. It's a little harder to see here, but you can see this piece is half of this portion of the rectangle, and this piece is half of this portion of the rectangle. So 25 times 7 is 175, divided by 2 is 87.5. Inches times inches is still inches squared. And we briefly saw a trapezoid. Now, a trapezoid is defined as a four-sided figure with one pair of parallel sides. The trapezoid, typically we see a trapezoid drawn like this. Where this side and this side are parallel. But a trapezoid can be drawn like this. We'd still have this side and this side parallel, or it could even be drawn like this, where it's the vertical sides now that are parallel. When we deal with a trapezoid, the two sides that are parallel are called the bases. One of them smaller than the other, so I'm going to label that with a little b, the other one with a big B. So in this trapezoid, we have those two bases, little b and big B. I'm going to put in some numbers here. Little b is going to be 8 inches. Big B here is going to be 28 inches. To find the area of this, we're actually going to turn it into a rectangle, just like the triangle, where we found that related rectangle. This, we're actually going to turn it into a rectangle itself. I'm going to go halfway down this slope surface, right about there, cut it off square, and flip that piece up. Remember, we looked at this in Unit 2. Do the same here. We go halfway down, we cut that little corner off square, and we flip it up. And we've now squared off that end. So now what we have here is a rectangle. First, the width of the rectangle here is whatever the height of the original trapezoid would be. This would be a height. It goes perpendicular actually to both bases, and it reaches the furthest point. So that'd be my height. And let's say that I put that height in there at 15 inches. So the width of that rectangle is still just the height of the trapezoid. The length of the rectangle from here to here is somewhere between the smaller base and the larger base. In fact, it's exactly halfway in between. So for the area of a trapezoid, the related rectangle has a length that's the average of the two bases, and then, of course, times that height to get the area. So for this trapezoid, we have a base of 8 and 28. So we'll add those together and divide by 2, and then times that height of 15. 8 plus 28 is 36. 36 divided by 2 is 18, and 18 times 15 is 270. That's inches and inches, so this will be inches squared. So the area of that trapezoid is 270 square inches. So if I give you a triangle, and I tell you this side is 8 inches, this side is 15 inches, and this side is 17 inches. But I don't mark an angle as being a right angle. How can we be sure? Well, to check for a right triangle, to see if that is a right triangle or not. First of all, in a right triangle, there are two sides that make the right angle. They're called legs. I go, it's called the leg there. So we have the two legs that make the right angle. I think because they form the L of the right triangle. The other side, the only side that does not touch the right angle, is called the hypotenuse. The hypotenuse will always be the longest side of a triangle, a right triangle especially. So looking over here is if this is a right triangle. (17) is the longest side. This would be, I say, possible hypotenuse because we don't know if that's a right triangle yet. But it's the longest side, so if this is a right triangle, that would have to be the hypotenuse, which means this would have to be a leg, and this would have to be a leg. The other thing we know about a right triangle is if I label my legs sides A and B, and my hypotenuse side C, we know there's a relationship. A squared plus B squared equals C squared. So if I look back at this triangle over here, I'll label my legs A and B, or my possible legs, I should say A and B, and my possible hypotenuse C, and I have to check, does 8 squared plus 15 squared equal, I put a question mark above the equal because I'm asking if they're equal. I don't know that they're equal. 17 squared is my possible hypotenuse. 8 squared is 64. 15 squared is 225. That adds up to 189. 17 squared is 189. So it does add up, which means this is a right triangle. And of course, the right angle has to be between the two shorter sides. Why do I need to be able to do that? Well, because now to find the area, this would be my base, this would be my height. Well, one of them's the base, one of them's the height. It doesn't matter which one. So it's 15 inches times 8 inches divided by 2 for 60 inches squared. The 17 doesn't play into the area because that's the hypotenuse. Which brings us to the next logical question. What happens when we check that triangle and it's not a right triangle? This one here, if this were a right triangle, the shorter sides here, the 5 and the 6 would have to be the legs, and the 7 would have to be the hypotenuse. A squared plus B squared would have to equal C squared. Well, does 5 squared plus 6 squared, again, the question mark above the equal sign because we don't know if they're equal, does that equal 7 squared? 5 squared is 25. 6 squared is 36, and 7 squared is 49. 25 plus 36 is 61. Nowhere near 49. So this is not a right triangle. But what if I still want to find the area of it? Well, it becomes a little bit more complicated process. But a Greek mathematician by the name of Huron came up with something called Huron's formula, sometimes just called Hero's formula. I don't know why it's been shortened to Hero, because the name is Huron. Saving one letter doesn't seem worth the abbreviation to me. But Huron's formula stated that if you have a triangle that doesn't have right, actually any triangle, even if it has a right angle, you can still find the area. But as long as you know all three sides. So if you know all three sides of a triangle, you can find the area by first finding the perimeter. Now remember, the perimeter is just adding up the sides. So we have 5 inches plus 6 inches plus 7 inches. Gives us a perimeter here of 18 inches. Well, then Huron defined a number that he called the semi-perimeter. And this was defined with the letter S, and that's just the perimeter divided by 2. So that's 18 inches divided by 2 would give us a semi-perimeter here of 9 inches. Huron's formula then states that the area of a triangle is equal to the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. Now, I usually label my triangle A, B, and C from smallest to largest just to make it easier to keep track of. So here my semi-perimeter is 9. 9 minus my shortest side here was the 5. Times 9 minus my next side is the 6. Times 9 minus my next side is the 7. So this is the square root of, I have 9. Well, 9 minus 5 is 4. 9 minus 6 is 3. 9 minus 7 is 2. So the square root of 9 times 4 is 36. Times 3 is 108. Times 2 is 260. Now when I put this in my calculator, I'm actually going to put in the 9 times 4 times 3 times 2. just to make sure I did that correctly. 14.696, 14.70 we're going to call it. That is the area of that triangle. The sides were in inches, so this is in square inches. Now that's kind of a tedious little formula, but it is a very handy little tool because we will run into triangles that are not right triangles, and we will need to find their areas. For example, a triangle like this. Let's say this is 27 feet. This is 29 feet. And let's call this here simply 6 feet. To find its area, we're going to find the perimeter. The perimeter will be 27 feet plus 29 feet plus 6 feet, which is going to be, what is that, 62 feet? I believe. Yep, 62 feet. So my semi-perimeter is 62 feet divided by 2, which is 31 feet. So the area will be 31 feet times 31 minus the 6 times 31 minus the 27 times 31 minus the 29. So notice we have the semi-perimeter in here by itself first. Oops. And then we have the semi-perimeter minus each of the sides as well. So that's the square root of 31 times 31 minus 6 is 25. Times 31 minus 27 is 4, and 31 minus 29 is 2. So again, I'm going to punch that in my calculator just like that. The square root of 31 times 25 times 4 times 2. Close my parentheses so it multiplies them first. 78.74. Those units are in feet, so this will be square feet. That is the area of that triangle. Anybody have any questions? Okay, so most of today was a review of stuff we've seen before. Just wanted to put them all together in one assignment, in one little package. So your homework for today, starting on page 408, exercise 12.2, 1 through 45, the odds. That's areas of rectangles and parallelograms. Page 415, exercise 12.3, 1 through 51, the odd. That'll be Pythagorean theorem, the a squared plus b squared equals c squared, and then dealing with some of the other odd shapes. So we have about 16 minutes left. If you'd like to get started on that, I'll be on the network here to answer any of your questions. Otherwise,